Hello and welcome to our first video on electromagnetic field theory. So I'm going to be solving the uh, quiz one, the quiz that we wrote on last week, or was it last 2 weeks? Now, so we are going straight to the questions. So quiz one, we have the first question. We have here. I have the first question. 3 points. A -4, 5, -1. Then point B -2, 3, and 1. And then point C -3, 7, and then -3, 7, and -6 are located in a rectangular coordinate system. Find I, the angle between A and B. I, a unit vector normal to both A and C. And then the last one, II, the volume of the triangular pyramid with their vertices A, B, and C. Now, looking at this question, first, let's start with the first one, I. So we have one, I. We are to find the angle between A and B. So what that means, we can just indicate the point. Let's say I have point A here. Then we know the coordinates to be -4, 5, -1. Okay. Now I can indicate the coordinate of B too. We have point B, and the coordinates are -2, 3, and then the last coordinate 1. All right, the last coordinate we have 1. Now, if we have this, we want to find the angle between these 2 points. So what that means, we look at it relative to an origin. So we get the position vector of each of the coordinates, the points that we have here. So we can have a position vector. We have a position vector here. So we can have OA in that case. And then we can have another position vector, meaning relative to what? To our origin O. Now that we've gotten this, so we can get the position vector OA is simply going toward vector A, which is going to be equals to -4 along the x-axis plus 5 along the y-axis, then minus along the z-axis. So this becomes our position vector OA. Now let's get OB. It's also going to be equals to vector B. That is going to be equals to -2 along the x-axis plus 3 along the y-axis, and the last one plus A along the z-axis. So we have these 2 vectors. Now if we were to find the angle between them, we have theta. We can label the angle between them theta. So we get this. So if you take the dot product, meaning vector A dot of vector B is going to be equals to the product of the magnitude of both 2 vectors, then times the cosine of the angle between the 2 points A and B. So based on this, we can make theta the subject. So we get cos inverse minus into bracket vector A dot product of vector B over magnitude of vector A times magnitude of vector B. So now that we know this formula, let's try and get first vector B dot product of vector A. That means we have here, we can just look at the coordinate. So the product of the corresponding coordinate. So -4 times -2 plus 5 times 3 plus minus 1 times 1. And this will give us, here will be 8 plus 15 minus 1. So 8 plus 15, that's going to 23. So minus 1, we get 22. That is for the dot product. Let's get the magnitude of vector B. But let's have vector A, right? Magnitude of vector A. That is going to be, the coordinates are minus 4. So you get minus 4 square plus 5 square plus minus 1 square. So this will be minus 4 square. That will be 16. 16 plus 5 squared, which is 25. So 25 plus 16 plus 1. So we get root 42. Now let's get the magnitude of vector B. That one too. We have minus 2 square plus 3 square plus 1 square. Minus 2 square, that will be 4 plus 3 square, which is 9. So 4 plus 9, that will be what? 13. 13 plus 1, 14. So you have root 14. Now that we've gotten the magnitude and then their dot product, so we can get theta to be equals to cos inverse. We have their dot products. The dot product, we got 22 divided by root 14 times root 42. So we get 22 divided by root 14 times root 42 then we take cos inverse, so get 24.87 degrees. So this becomes the solution for I. So let's move to II. Now when it comes to II, we are asked to find the unit vector, which is normal to both A and C, this time A and C. So if this time, imagine we have our point A here, and then we have point C2 here, right? So point C, the coordinates are giving us minus 3, 7, minus 6. So minus 3, 7, minus 6. And that of A is minus 4, 5, minus 1. Minus 4, 5, minus 1. So this is A. So if we are asked to find the unit vector, which is going to be normal to point A and C, what that means is that, again, we are going to get the origin. We look at the position vector for each of the coordinates that we have here. So we get something of this nature. So if we want to find a unit vector that is going to be normal to what? Both point A and C, what that means is that both point A and C, they are going to form a plane, right? So we get a plane. If they form a plane, and that plane is going to be equals to the cross product of vector A and C. So if we have that plane, which is a parallelogram, what that means that now we can look at the unit vector, which is going to be what? Normal to this plane. So we have this plane. Now that we've gotten the plane, which is here, we can get the unit vector, which is normal to it. So, and before that, this plane is going to form as a result of the cross product. So first, we have to get the cross product of vector A and that of C. And then the unit vector in this case is going to be equals to unit vector normal to this will be equals. the cross product of vector A and vector C all over their magnitude, right? So the magnitude, the cross product, the magnitude of what the cross product. Now that we've gotten this is the formula. Now let's try and get the cross product of vector A and then vector C. So we put here plus, here we minus, we have plus here. Now we put the coordinates. So the first, we have vector A, so the coordinates of vector A will be what? -4, 5, -1, right? Then that of C will be -3, 7, -6. So we have this. To getting the cross product just similar to now finding the determinant of the matrix that is here. So that will equal to get A along the x-axis into brackets, meaning first column, first line is going, so we have 5 times -6 minus 1. Okay, let me use, so first we look at this. So we have 5 times -6, then minus into brackets, -1 times 7. So that is for this part. Now we bring here, you have minus unit vector along the y-axis into brackets. So this time we are taking we take the second column first line. Now we have -4 times -6 minus into brackets, -1 times -3 and close the bracket. Then we come near the last one, which is plus along the z-axis into bracket. So we do for this one, which is going to be, we cancel again, third column, first line. Now we are going to have -4 times 7 -3 times 5, then bracket close. Now that we've gotten this, so let's simplify this. So -5 times minus is, we get -30. So we have here minus into brackets -1 times 7. So that will be -7. So meaning we are having, in this case, we have -30. Right, this is minus, so meaning minus become plus. So we have -30 plus 7. -30, that will be -23. Okay, so we get this. Now let's try and get the next one. So here we have minus 4 times -6. That will be +4. Then into brackets here we have -1 times -3. We get here 3. So 24 minus 3, we get 21. We have another minus here. So we have -21 along the y-axis. And the last one, try and get this one. This one to -4 times 7. That will be -28, right? Oh, is it -21? So -4 times 7. Yeah, -28. Then we have -3 times 5. We have -15. So you can see here is going to be, again, we are going to have -20 minus. So that's -20 plus 15. That's -13 along the z-axis. So this is our cross product All right. Now, let's try and get the magnitude of this cross product. So we have the magnitude just be minus 23 square plus minus 21 square plus minus 13 square. We take the square roots. So we have 23 square plus 21 square plus 13 square. Then square root of that will give us 33.75. Now we replace this in the formula. So the unit vector normal to the point A and C is going to be equals to in the vector, which is minus 1 over this 33.75 minus 23 along the x-axis minus 21 along the y-axis minus 13 along the z-axis. So this is going to give us, meaning we are taking minus 23 divided by 33.75. We get here minus 0.68 along the x-axis. Then here we minus, so here we now have 21. So we get here minus 0.62 along the y-axis. Then the last one, we have minus 13 divided by 33.75. We get minus 0.39 along the axis. So this becomes the solution for II. So let's move to the next question, which is II. So II, we are being told to find the volume of the triangular pyramid with the vertices A, B, and C. So if we are to find the volume of the triangular pyramid, what that means is that when it comes to the volume of a triangular pyramid, right? So the formula is going to be equal to 1/6 of what? The mixed product of what? The vertices. So meaning we have, let's say, in this case, we can take A, right? A cross product of vector B, and then dot of what? Vector C. And then we take the magnitude of this, right? The magnitude of that. So this is the same as we can calculate this part here. That means the cross product of vector. We can even do it this way, right? We already know the cross product. We can even write another formula. Okay, let's use that one. Okay. I've even used this formula. I've just realized it. So let's try and then try to save time. Let me use this one and see. We should get the same answer. So here, let's say this time we are taking cross product of vector C, then dot of what? Vector B. So let me put vector B here. Vector B. Let's do it this way. Right. Now, so let's solve it. Okay. And that means I'm having cross products of vector A and C, then dot of what? Vector B. Right? So we know cross product of vector A And C is what we got here, which is minus. So I can write here minus 23 along the x-axis, minus 21 along the y-axis, minus 18 along the z-axis, dot of what? A vector. Dot of now vector b. And then we know vector b. How can we find vector b? We can find vector b by what? Because we know the coordinates. The coordinates are giving us minus 2, 3a. So I can write here minus 2 along the x-axis plus 3 along the y-axis, then plus along the z-axis. So let me get this right. So we have minus 2, 3. Very good. So this is now, we can get the dot product of this, and the dot product here is simply going to what? The sum of what? The product of what? The corresponding coordinates. So we have minus 23 times minus 2 plus minus 21 times 3 plus minus 13 times 1. So here minus 23. So here will be what? 46, right? Plus minus 21 times 3. So give us minus 63. Then plus minus, or you can say minus 13. So here plus 46 minus 13. So we get here to be minus 30. Very good. So we've gotten minus 30. Now we can come and replace. So we can use V1. Let's use V1 to represent the volume of what? The triangular pyramid. So I can write here 1 over 6 absolute of vector A cross product vector C, then dot of vector B. Then you take this. So we have 1 over 6 minus 30. So we get here to be 30 divided by 6. That will be 5, right? Divided by 6. So we get here to be 5 cubic units. So we get 5 cubic units. So this is how we solve question 1. So we'll be solving the next question, which is question 2 in the next video. Bye-bye.